Right, good afternoon. Thank you for joining Heidelberg Materials on our fantastic stand today at Future Build. I'm going to try and explain to you over the next 5-10 minutes carbon capture. Really quite simple, but hopefully it will answer some of the questions that we've had over the last few days. So hopefully you can all hear me. I'm Marian Garfield and I'm the Sustainability Director for the Heidelberg Materials Group in the UK. So obviously the whole Future Build thing is really up my street, and I've been really enjoying the last 2 days. I think the first thing we always get asked, and we've had this a few times now, is why do we need carbon capture? It's technology, do we really need it? Is it not an alternative to getting to a net zero position? So in terms of Heidelberg Materials, we want to be net zero by 2050. And one of the biggest challenges we've got is our cement manufacturing process. So we are 70% of the CO2 that comes from cement comes from the process emissions. So we've done a lot of work in the last 20-30 years around the 30%. So the 30% comes from the fuels. So traditionally that would be coal. And we've done some fantastic work in the UK but around the globe about how we decarbonise the fuel strategy. And if you've come to the stand or after this presentation, come to the stand and we can show you that the types of fuels that we're using in the cement kilns today. We've had some really good successes in the 3 cement works in the UK. We've had some net zero fuel mixes. Elliot mentioned earlier on about the hydrogen trial at Ribblesdale 2 or 3 years ago, and this year in Ketton we actually had no coal on the process for 2 or 3 days. We had a complete zero net zero fuel mix. So the challenge is this 70%. So how do we get to net zero when the chemical composition of making cement is by taking the limestone out of the ground, heating it up to very high temperatures, and obviously that natural process, the CO2 comes from the natural process. So for us all to get to a net zero position, so for industry, so for the UK PLC, for the construction industry to get to net zero, we need to make net zero cement. And we realise that the only way to do that is through carbon capture. So this is our cement works in Padeswood in North Wales. If you've never been to a cement work, this is what one looks like. It's quite an ordinary setup. The cement works has been there for about the last 60-70 years, so it's well established in the community. It employs about 120-130 direct jobs plus some additional secondary jobs as well in the area. And our ambition is to have an operating CCS capture plan on this cement works by 2028, 2029. So the question that everyone asks us is, how does it work? So how does it all work? What does it look like? So this is a relatively new slide, so I'm going to try and talk through the process of how we capture the carbon and then what do we do with the carbon once we captured it. So carbon capture technology is not new, okay? It's been around for the last 25-30 years. What is the nuance or the new bit of this is attaching it to a cement work. So we are the first country in the world, or company in the world, to have a carbon capture plant attached to a cement works, and I'll mention that in a little bit, but it's our cement works in Brevik. But this is the same technology we're using in Brevik that we're bringing over to Padeswood. So basically, you've got the kiln line here, which is where we heat the limestone and we produce the clinker that makes the cement. And what we're doing is, a traditional cement works will have a preheater tower. What we're doing is we're then capturing the flue gas, which contains the CO2 from the preheater tower in a cement work. So this is all current process, okay? So at the moment, this flue gas would currently just go directly out the flue. What the new technology is in terms of carbon capture is, we take the gas, we take it through a bag filter that removes some of the NOx and SOx and some of the dust emissions that are currently there, and we put it through a combined heat and power plant. So we heat it up to get to a temperature, and then this is the new bit. This is where the exciting carbon capture technology works. We have an absorber tower which is about the same height as our preheater tower, a little bit higher, and I'll show you what a visualization model will look like at Padeswood in the next slide. And this is where the the CO2 gets mixed and goes through a heat exchanger, and then in here is where the technology really works. So we have an amine solution, which is a solvent-based solution, and what happens is the CO2 from the flue gas is combined with the amine solution and they stick together, and this happens all through here, and the rich solution goes through the heat exchanger, it gets heated again, and then what happens is with the heat exchange and the heat differences, the CO2 gets stripped from the amine solution and the CO2 gas rises to the top from here and gets taken out to a compressor, and then what happens is the amine solution gets recirculated back, so it's nearly a closed system in terms of the amine solution, gets taken back through into the heat exchanger for the process to continue. And then what happens is you've got this pretty pure, I think it's about 96-97% pure CO2 that leaves this tower and goes into a compressor and through to a pipeline. And one of the questions is what happens to the CO2 from the Padeswood manufacturing facility. So this is what it will look like. So you've got your cement works here. So imagine this is Padeswood. What happens is then Padeswood is in the North Wales on the North Wales coast. If you can imagine that, it's in the HyNet consortium region. And one of the questions we get asked is why have we chosen Padeswood? We've got 3 cement works in the UK. Why have we chosen Padeswood to put this technology on? And one of the simplest questions, the simplest answer is Padeswood is about 7 or 8 kilometres from a main pipework network in terms of a CO2 network to transport it away. And what happens is we will connect to the mainline CO2 network, which has been developed by Eni, and they will then transport that to the point of air facility in Flintshire, and it gets compressed and taken into the Liverpool Bay, where it's stored into the geological deposits around the UK. So it's a pretty straightforward process. It gets piped. Our process is slightly more simple than the Brevik, where the Brevik's been taken on a ship and taken to the Northern Lights. So our process is a little bit more simpler, and if you've looked at our video on the stand, you'll see a ship being compressed and decompressed and then taken into the storage. Ours is going direct to pipe through and then deposited into the Liverpool Bay area. So this is what it looks like. So we are currently we've submitted our final papers to government, and we're hoping for a positive decision in the next few months in terms of this project really coming to life. This is the current cement works at Padeswood. So this is the preheater tower which I was telling you about, and if you've ever visited any cement works, you'll always see a tower of that nature, and you can see this is our sort of artist's impression of what the carbon capture plant will actually look like. So that's sort of the absorber tower that we were talking about, where all the amine solution gets stripped and the CO2 comes out. So you can see it's going to just sit nicely alongside the current cement works in Padeswood. In terms of our global ambition, so the question we get asked is how confident are we going to be as a company around carbon capture? Is it proven technology? How confident are we? Well, we're confident enough in the fact that we've invested 1.5 billion. So Heidelberg Materials around the globe have got these projects that's live projects. They're all in different stages of in terms of carbon capture project stage gates. Some are in feasibility, some are in pre-feed, and the most exciting one is the one up in the top corner there, Brevik. Brevik is built, it's commissioned, it's going through its last stages of sort of technical commissioning, and it's going to be live producing net zero cement by September, October time this year. So as a UK construction industry, as a material supplier into that construction industry, Heidelberg Materials will be able to provide you with net zero cement this year, and which is a fantastic opportunity for us, but also for us decarbonising the industry. So final slide for me is it's here, it's a reality, it works, the technology's there, it's been put onto a cement works in Brevik, it's coming to Padeswood, it's going to be in Padeswood in 2028, 29, and we're here to answer any questions or any feedback that you have in terms of net zero. So please talk to people on the stand. We've got some fantastic technical experts in terms of low carbon materials. We've got some fantastic commercial guys who want to talk to you about Evo Zero and the opportunities it has for small projects, but also large projects as well. So final thoughts for me, we're here to help you meet your climate targets with Evo Zero. We can demonstrate, Evo Zero cement is no different to normal CEM 1. The process hasn't changed. The technical capabilities of cement doesn't change. It's exactly the same material. All it does is have net zero carbon into that material. And we want to be seen. We want to help you guys deliver your sustainability goals. We want to be seen as the leader in this industry, and we're here to support you with your net zero goals.